right, so now we're going to look at ways we can use those properties of logs in order to simplify some other types of logarithmic expressions. So here we're looking at what if I don't have a calculator and I need to evaluate some common logs that aren't real easy. So log 4, log 6, log 12, all these listed here. If I know, because I'm really smart and I just happen to know, that log base 10 of 2 is 0.301 and log 3 is 0.477, I actually don't need a calculator to find these other logs. Let me show you how I do that. So I can take that log 4 and I can rewrite it as log 2 squared. And then I can use that third property of logs to move that 2 out front. So this is 2 log 2, which means it's 2 times 0.301, which is 0.602. So I didn't need a calculator, I just needed to know a little bit of something about how to write log 4 in terms of 2, and then do a little bit of math using that log 2 equals 0.301. So given one simple log 2, I can actually find log 4. If I also would know log 3, I can find log 6. So I could rewrite log 6 as log of 2 times 3, because 2 times 3 is 6. And then I can separate that. So remember the property of logarithms that says I can separate multiplication with addition. So log 2 plus log 3. And then I put those values in here. Log 2 is 0.301, log 3 is 0.477, and when I add those two together, I get 0.778. And so I can continue that process. I could write log 12 as log of 4 times 3. Why would I use 4? Because I already know 4. I found 4 in this first one, so 0.602, and I could use that here in this third one. For 27, I would write it as log of 3 cubed, so 3 log 3, and I would use that value. 24, I could do 24 a couple of different ways. You have your choice on 24. I could do log of 3 times 2 cubed, that would be 3 times 8. Or I could do 4 times 6. And since I have 4 and 6 already on my paper, I could use those. If you're given a question like this, you can use numbers you found as long as they're shown right there on your paper. So I can use 4 and 6 right from here because I've already shown them on my page. Okay? Again, no calculator, so you're going to have to find them first in order to use them. The last one here is one I like because it's one I think we overlook. I can get 1.5 by doing log of 3 halves, 3 over 2. And remember, if I'm dividing 3 divided by 2, that would be log 3 minus log 2. The denominator, the 2, is a negative term when I split it up. And then I could plug in those values, 0.477 minus 0.301, and I could get a value for log of 1.5, again without a calculator, of 0.176. If you'd like to do the other ones, you can go ahead and do those. Take a minute to simplify those. The answers are, so pause your video and come back if you need to. The answers are 1.079 for 12. 27 is 1.431. And 24 is 1.380. All right. Good to know for an exam or a test, or maybe you forget your calculator. If you happen to have log 2 or 3 memorized, you can actually do some of these other logs. Okay. Another application of the properties of logs are some equations that are a little bit more than the basic converting equations that we did before, but they're really just one step more. So the first step would be to combine. Second step would be convert. Third step, solve. And then the fourth step is always to check that our answers work and make sense. So let's do a couple of these equations here. So what I mean when I say combine, convert, solve, and check. So combine. Start with any logs that I have on the same side of my equal sign I can put together. So there's my equal sign. On the left, I have log base 3 and log base 3. I'm adding, so I can write this log base 3 of x times 3, or 3x, however you want to write that. And that equals 1. So that's my step 1, combine. Then I'm going to convert. So I'm going to convert this logarithmic equation into an exponential equation. Why? So that I can get this x here out of the log. So I'm going to write this as 3 to the first power equals 3x. 3 equals 3x, and now I just have an equation I can solve. Step 3, solve. Divide by 3, x equals 1. And then I want to check, so I want to go back and check that that makes sense. Okay, now I can go back to the beginning and I can put in a 1 right here, but that probably doesn't help me because 3 to what power is 1? Well, that one might help me. 3 to what power is 3? Yeah, that one does. Sometimes you can't actually do anything with this log, these logs here. You're putting in a number that you can't really do anything with. So I would probably go to this second step in the purple where I combined and I'd plug it in there and see that it made sense. Okay, so you're just kind of going back and checking your work. So in this case, I could actually simplify each of these. Log base 3 of 1. Remember, anything with a 1 inside the log here is 0. Base 3 of 3 is 1. 3 to the first power is 3, so 0 plus 1 equals 1. It does work. Okay. All right, so that's how we can use properties to help us solve some of these other types of equations. Let's do the second one here. Again, on my left side, I can combine these two log base 3's. And I'm going to have x times 2, so 2x, and that equals 2. Convert, 3 squared equals 2x. Solve. So 3 squared is 9 divided by 2, x equals 9 halves, or 4.5. This is one of those cases where I could plug it in right here and write 9 halves, but that's not going to help me, right? I can't say, oh yeah, I know that's true, like we do when we check a lot of equations. But I could plug it in here to the second after I converted and say, well, 2 times 9 halves is 9, and 3 squared is in fact 9. So I can just kind of double check that it really does work. All right, I think we'll stop after those two examples. We don't have to do the other two. And we're going to go on to more equations. So we're going to start looking at some slightly more complicated equations and how we solve those. So to solve an exponential equation, we get the exponential term by itself. We take the natural log or log, either one of both sides. It'll be your choice if you want to use natural log or log. Okay, some cases you might want to use one over the other. Most of the time, it doesn't matter which one you pick. Okay, you'll take the exponents out. Remember, they are coefficients of logs. An exponent becomes a coefficient. And then you're going to solve for your variable. Leave the answer exact or round to 3 decimal places. So depending on how the teacher in your class wants you to answer that question, you've got 2 options. For me, I'd rather just leave it exact. But if it's something where we need that decimal, use 3 places, okay? So let's look at an example of this. Really basic example. 2 to the x equals 5. So 2 to what power equals 5? So here's how I can write that. I can write this, first isolate my exponential term. It's already done, so I'm really just jumping into the second step. If I take the natural log or log of both sides, now I have natural log of 2x equals natural log 5. I can take this exponent x out as a coefficient. And then I can divide the left side to get x by itself. I can divide by natural log 2. Same thing on the right. So x equals natural log 5 over natural log 2. Now, I know some of you are like, oh, I'm dividing, so let's just combine those together. But remember, the property says if I have a log and inside that log I'm dividing, I can separate with subtraction. There is no property that says if I'm dividing logs, I can somehow put those together. Okay? So keep that in mind. Let's keep going. What if I have something like, I'm going to skip the second example and go straight to the third. We're just going to go straight after it here. 2 times 10 to the x minus 4 equals 12. First step, get the whatever is being raised to a power, get that by itself. So get my exponential term all by itself. So I'm going to add 4, just like any other equation, and I'm going to divide by 2. So I get 10 to the x equals 8. Take the natural log of both sides. Bring that exponent out front. So x times natural log 10 equals natural log 8. I got ahead of myself. Divide both sides by natural log 10. And x equals natural log 8 over natural log 10. Now you may be thinking to yourself, all right, these don't really look easy, right? These don't look pretty. Those aren't nice whole numbers. They don't look nice. And you're right, they don't most of the time, okay? You may also be wondering, all right, why is she using natural log? Why not log? Well, this is a great example to talk about when I could use log. So if I would say, instead of natural log, let's say I said log. So let me change my natural logs to common logs. Just going to write right over the top of my natural log there. What happens if I use natural log? Well, if I use natural log, this denominator, log 10, remember log is a base 10 of 10. So 10 to what power is 10? Well, that's easy. It's just 1. So I can actually put a 1 in the denominator here. So then x would really only be equal to log 8. And I can simplify it even more if I use log instead of natural log. Now, if you use your calculator, so if you take your calculator and you want to plug in that answer to get a decimal, you can do that. And you can do natural log 8 over natural log 10, or you can just do log 8. And what's really cool is no matter which one you do, so if you try them both, natural log 8 over natural log 10, or just plain log, common log 8, for both of those, you're going to get 0.903 for both. If you don't believe me, go do it now. Pause your video and go try it. Okay? Kind of cool how it works. So for example 4, again, we're same process. Isolate your exponential term here. So I'm going to divide by 3. And then because my base is e, I am definitely going to use natural log here. Because again, the natural log and the e go together. So then I pull my exponent out front. And because natural log is base e, and it's of e, this equals 1. So it's really just 2x equals natural log 8. Divide by 2. X equals natural log 8 over 2. If you need to get a decimal approximation for that, it's approximately 1.039. So again, either have an exact answer or 3 decimal places. All right? So that's exponential equations. All right, third and last video will be next, and on that one we're going to solve logarithmic equations. So what if I have a log in the equation I need to solve? All right, so come back for that one.